Good day everyone. By the way, my name is Lovely Bitalaid Buenaflor, one of the reporter of Group 5. So our topic is all about normal distribution. So our objective for today is identify the properties of a normal distribution, determine normal and non-normal distribution, find the areas under the normal curve, transform variable to a normal random variable, apply the properties of the normal distribution to real-world problem. So what is normal distribution? So normal distribution is a continuous probability distribution. This means that it is generally uses either interval or ratio data. The histogram is a great approximation of a normal distribution. Drawing a bell-shaped curve on the histogram determines if the data follows a normal distribution. A bell-shaped curve symbolizes that there is one central peak. The rest of the data are on either side of the center tapering on the extremes. This is the normal distribution. It's also called a bell-shaped curve because it is a symmetrical curve that looks like a bell. The middle or the center of the bell curve is the mean, median, and mode. And it always represents as 0. The negative 1, 2, and 3, and the positive 1, 2, and 3 is the standard deviation. And the both side of the bell curve is called the symmetrical sides. And the last part or the tail of the bell curve is called the symptotic tail. Determine normal and non-normal distribution. The first method that almost everyone knows is the histogram. The histogram is a data visualization that shows the distribution of a variable. It gives us the frequency of occurrence per value in the dataset, which is what distribution are about. The histogram is a great way to quickly visualize the distribution of a single variable. In the picture below, two histograms show a normal distribution and non-normal distribution. On the left picture, there is very little division of the sample distribution from the theoretical bell curve distribution. And on the right picture, we see quite a different shape in the histogram, telling us directly that this is not normal distribution. A normal distribution has the following properties. First, it is bell-shaped curve. Second, the total are under a normal curve is 1. Third, the tail of the normal curve are asymptotic to the horizontal axis. And the fourth, the curve is asymmetrical to the mean. And the fifth, it is determined by the population mean and population standard deviation. The mean controls the center and the standard deviation control the spread of the distribution. And the last, the mean, median, and mode have the same value. It was states that the normal distribution is asymmetric about the mean. This signifies that the areas of a z-value are the same, whether it is positive or negative. Hence, area of negative z is equal to the area of positive z. The concept of probability is used for normal distribution. Probabilities are from 0 to 1. This means that the value of areas cannot be negative. Moreover, they also cannot have value greater than 1. The notation will be used as their meanings are as follows. Is read as the probability or area of z between A and B. Is read as the probability or area of z less than A or to the left of A. Is read as the probability or area of z greater than A or to the right of z. Remember that the symbol greater than or equal to and less than or equal to have the same meaning as greater than and less than. To find the areas, the table of areas under the normal curve will be used. The table is also known as the z-table. So this is the table under the normal curve. Don't worry because I will send this table to our GC after our reporting. And you can open our PPT that I already sent to our GC because the table is already placed there. But you can search to the Google too. So it means there's a lot of choices kaya walay basihan na dili ka makasave sa table. The table is important because all the answer will be here in the table. I know some of you is familiar of this because this is already tackled when we was grade 11 and expected that all of you will be know how to use the table. To find the areas under the normal curve, 3 things must be done. First, draw the normal curve. Second, shade the appropriate region. Third, calculate the area by using the table of areas under the normal curve. So here are some examples. So the given problem are the probability of negative 0.72 less than z and less than 0. So here are the first step. You will draw a bell-shaped curve. You will make a line at the center which is the mean, median, and mode that always represent as 0, and you can write the standard deviation which is the negative 1, negative 2, and negative 3, and positive 1, and positive 2, and positive 3. And the second step is you will draw again the bell-shaped curve. You will make a line at the center, write the mean, median, mode, and the standard deviation. And you will shade the appropriate region which is the negative 0.72. Since the positive region is 0, so you don't need to shade the positive region. And the third step is you will write the answer. Therefore, the answer is 0.2642. If you will ask him bakit ang 0.2642 yung answer, because you will calculate the area by using the table of areas under the normal curve. So 0.72. So you will find the 0.7 and 0.02 at the table. That's why the 0.7 and 0.02 is under the 0.2642. That's why the answer is 0.2642. The given problem of example number 2 is the probability of 0 less than z and less than 1.83. So, let's proceed to the second step. So, you will shade the appropriate region of the positive side which is the 1.83. So, the answer is 0.4664. Because under the 1.8 and 0.03 is 0.4664.
Hi guys, this is Angel Rose Ortiz and I will be going to add more examples in calculating the area by using the table of areas under the normal curve. So first example is P, open parenthesis, negative 2.58 less than the standard normal score, less than positive 2.58 and close parenthesis. So first we will draw a normal curve, then label it. The mean is 0. Then on the left side is negative 1, negative 2, and negative 3. And on the right, the positive 1, positive 2, and positive 3. So second, we will locating the 2.58. So this line, this indicate the 2.58, the positive 2.58, and then this line indicates the negative 2.58. So the problem here is a negative 2.58 less than the standard normal score, less than positive 2.58. So therefore, we will have to shade from the positive 2.58 and to the negative 2.58 including the mean. Since the mean is included in the shaded region, the areas must be added. Therefore, using the z table, we will locate the the z-score or the value of 2.58. So use your z-table and find the value of 2.58. So 2.58, by looking at your z-table, it is equals to 0.4951. So again, since the mean is included in the shaded region, the areas must be added. So 0.4951 plus 0.4951 is equals to 0.9902. So 0.9902 is the area of this problem, or 0.9902 is the answer. Another example, E open parenthesis standard normal score, then less than positive 1.44. So again, we will draw a normal curve. So right now, we will locate the 1.44. So after locating the 1.44, so this line indicates the positive 1.44. So our problem is the standard normal score is less than 1.44. So from the positive 1.44 to the left, all part on the left will be shaded. So after shading, this is the result from 1.44 to the left. So since the mean is included in the shaded region and the area to the left of the mean is shaded, the area of 1.44 is to be added to 0.5. So why would we add 0.5 to the area of 1.44? Because all part of the left is included. This part is equivalent of this part is 0.5. Each side of this normal curve is equivalent to 0.5, or the 50% of this whole normal curve. So since it is shaded, included in the shaded region, so we will add 1.44 to 0.5. Example, P open parenthesis standard normal score curve is greater than 1.95. So right now, we will draw the normal curve, and then this line indicates the 1.9 here. This line indicates the 1.95. So our problem is, the given problem here is the standard normal score is greater than 1.95. So from this line, 1.95, to the extreme right, because the problem is the standard normal score is greater than 1.95. So we will be shading from 1.95 to the extreme right, like this. So since the shaded area is on the extreme right, the area of 1.95 must be subtracted from 0.5. So why we subtracted 0.4744 to 0.5? Is it because the standard normal score is not included in the shaded region, because the standard normal score is greater than the 1.95? So the shaded part only is from the 1.95 to the extreme right of it. So change 0.5 minus 0.4744 is equals to 0.0256. So 0.4744 is the equivalent of 1.95, or the z. So here. So we will now locate or find the value of 1.44 in your z-table. So we will find it 0.4251. So again, since the mean is included in the shaded region, the area to the left of the mean is shaded, the area of 1.44 is to be added to 0.5. So 0.4251 plus 0.5 is equals to 0.9251. The 0.9251 is the area of the shaded part. We're going to another problem. If the areas are given, what are the values of z? So right now, I will give you some examples. So first example, find the z-score such that p, standard normal score, is greater than the z-score, equals to 0.0125. So since the area is given is less than 0.5, the shaded area is on the extreme left or right. So however, looking at the direction, it can be seen that the shaded area is at the extreme right. Because of the problem, the standard normal score is greater than the z-score. So we'll assume that it will be in the extreme right. So since the shaded area is an extreme right, the area of 0.125 must be subtracted from 0.5. So 0.5 minus 0.0125 is equals to 0.4875. So we will find the z-score. Look at the z-score on the z-table. The z-score of 0.4875. So you'll find it there, 2.24. The z-score of 0.4875 is 2.24. We'll proceed to another problem. If the areas are given, what are the values of z? So I will give you some examples. So first example, find the z-score such that p, standard normal score, is greater than the z-score, equals to 0.0125. So since the area is given, since the area given is less than 0.5, the shaded area is on the extreme left or right. However, looking at the direction, it can be seen that the shaded area is at the extreme right. So why did we shade the extreme right? Because of the problem, because the standard normal score is greater than the z-score. So since the shaded area is on the extreme right, the area of 0.0125 must be subtracted from 0.5. So 0.5 minus 0.0125 is equals to 0.4875. So the z-score of 0.4875 is 2.24. We'll find it in the z-table. Looking at your z-table, you will find the value or the z-score of 0.4875 is 2.24. Another example, find the value of positive, negative z-score such that the area 0.8452. So since the area given is more than 0.5 and there are two variables of z-score to be obtained, 0.8452 has to be divided into 2. So 0.8452 divided into 2 is equals to 0.4226. So looking at the z-table, the closest value is the closest to 0.4226 is 0.4222, which is the z-score is equals to 1.42. So now, in finding the value of positive negative z-score, the positive negative z-score is positive negative 1.42. So that's why we shaded this area. Last example in finding the value of z if the area is given. So find the value of z-score if the highest 77% of the data is to be considered. So we'll turn 77% into decimal. So 0.77 minus the 0.5. So the shaded area of the highest 77% of the data is shown. Since the value of z is below the mean, it is negative. The shaded area from the mean to the extreme right is 0.5. To get the z-score, we'll subtract 0.77 to 0.5. So 0.77 minus 0.5 is equals to 0.27 or 0.2700. So looking at the z table, the closest, we will find the closest to the 0.2700 is to z is 0.2700, which is the z-score is 0.74. So the z-score of this problem, so the z-score, if the highest 77% of the data is to be considered, is negative 0.74. So why it is negative? Since the z value is below the mean, it is negative. So the z-score is negative 0.74.
Good morning, classmates. My name is Bert James Matila. I am the reporter of the Group 5. My topic is standard normal score. We have two examples here. The problem of Edna . So this is the first problem. 13 students who took the final exam last term have a mean grade of 34.08 and standard deviation of 7.62. What is the probability that Edna will get more than 40 in the final exam? So ayun dito guys, no? Ay stay classmate. Ano daw ang posible bang makakuha si Edna ng 40 more or 40 above sa ilahang exam? To solve that, we need to use the z-score formula or standard deviation. Let me show you. So this is the formula of the standard normal score or z-score. We have x, random variable, m, puro siya Q na pagkasulat. So iyang kuan kay mean, mo na siya ang mean. We have O, yun ay bagit sa ibabaw, pinabagit. Mo na siya ang standard deviation, and this is the final formula. Z equals x negative m. The summary kanina sa ating pinakitang problem, we have 40, the possible get more than 40 in the final exam of Edna, and kanina given din yung mean at saka standard deviation, which is the mean is 34.08 and the standard deviation of 7.62. Tapos na tayong makuha ang ating z-score, which is 0.78, pwede na tayong gumawa ng normal curve, which is ito. Yan. Dito sa gitna, ito yung mean. Equivalent yan is 0. Yan. At importante lang kalaman is dito lahat positive. Yan, dito. Dito sa kabila, negative yan lahat. Negative. Dahil ang ating z-score is positive 0.78, dito natin siya ilalagay dito sa may kanan dito. Huwag nyo ilalagay dito sa kaliwa dahil mali kayo dyan. Positive yan lahat. Dito natin ilalagay. Gawa-gawa ko lang to, di bali na. Dito z equals 0.78. yan. Pagkatapos nyan, pwede na tayong mag-conclude dito. Therefore, the area of natin ang problema ni Edna, we need to use the Z-score formula, which is ito. Yan. And dito, lagay natin ito sa ibaba. Z equals 40, which is ito, the variable. And minus, lagay din natin ito yung mean, which is 34.08. And the standard deviation, which is dito, sa baba. And para makuha natin itong 0.78, we need to 40 minus 34.8. Pagkatapos nyo ma-minus, divide nyo dito sa 7.62. And the result is 0.78. Gets nyo? Yan. So, dito tayo sa problem B ni Edna. What is the probability that Edna will get a score between and 30? 30 and 40, sorry. 30 and 40. May chance ba daw makakuha si Edna ng 30 and 40 score sa kanilang final exam? So, punta na tayo sa ating Z-score para malalaman natin kung makakuha nga ba si Edna ng 30 and 40. Nating Z-score. Copy na Z-score formula dito sa itaas. And dito naman tayo sa ating X is 30 dahil 30 and 40 yung binigay nila kanina. 30 and 40. Dito sa baba naman, copy the mean. Ang mean natin kanina is 34.08. Yun lang din ating gagamitin, at yung standard deviation, yun lang din. Ito, 34.08 and 7.62. Susunod sa baba, copy the Z equals 30 minus 34.08. Kagaya lang din ng kanina, we need to minus 30 minus 34.08. At ano yung lalabas sa pag-minus nyo? Ita times nyo lang dito. Ay times divide nyo lang sa 7.62. At ang lalabas dyan is negative 0.54. Yan yung lalabas. Gets nyo classmates? Dito naman tayo sa kabila. Ganun lang din, same lang din dito. Ganun itong gagawin. We have 40 ang ating variable, and mean, copy natin mean 34.08, and the standard deviation, which is 7.62. So, copy the Z equals 40 minus 34.08. Pareha lang din yung dun kanina. We need to minus, and the result, we need to divide of 7.62, and the result is 0.78. Yan. Itong dalawa. Pagkatapos nyong makuha itong Z-score natin, gagawa naman tayo na dito, normal curve. Ito, normal curve. Itong gagawin natin. Ang sagot natin sa sa 30 score is 0.54, ay negative 0.54. Dahil negative siya, dito natin siya ilalagay sa kaliwa. Dahil negative dito, negative. Dito sa kanan, positive. Dahil negative siya, kibali, dito natin siya ilalagay. Diyan. Dito. Negative 0.54. Yan. At ito, dahil positive itong dito, 0.78, lalagay natin siya dito sa kanan. 0.78. Yan. Kuha nyo? Very good. So, pagkatapos natin dyan, pwede tayo mag-conclude. Therefore, the area of negative 0.54 and 0.78 are added. The answer is 0.4231. This means that Edna has a 42.31% chance of getting a score between 30 and 40. So, may posibleng makakuha si Edna ng 30 and 40 sa kanilang exam. Yan lang, sana masundan nyo. Peace. So dito naman tayo sa ating problem number 2. The average age of a Filipino man to undergo the sacrament of matrimony is 29 with a standard deviation of 2.5 years. Richard, age 26, is contemplating if he should marry already. What is the probability that he will marry before he reaches 30? So dito guys, given na din yung ating mean, which is 29, and the standard deviation of 2.5. And ating variable dito is 26 and 30. Yan. So, punta na tayo sa ating z-score formula. So, dito na tayo sa ating z-score. Gaya lang din kanina, copy the formula, which is z equals x negative m over sigma or 0. Which is, ang ating variable is 26, that is the age of Richard. Lagay natin dito. And ating mean kanina is given na. We need to copy, that is 29, and the standard deviation is 2.5. Yan. Pagkatapos yung malagay dyan, dito naman tayo. Isosolve na natin. Copy the z equals 29 minus 26 minus 29. Pagkatapos yung ma-minus, kung ano yung lalabas doon na answer, we need to divide this. I-divide natin siya sa 2.5, which is the result is negative 1.2. Yan. Yan. Kuha. Good. Dahil tapos na tayo dito naman tayo sa kabila, which is the variable is 30. The probability that he will marry before he reaches 30. Yan, dito tayo. Kaya lang dito sa kabila, copy the mean, which is 29, and the standard deviation of 2.5. Same lang ng process din dito. Copy the z, 30 minus 29. Pagkatapos yung ma-minus at ano yung lalabas na result, i-divide lang diri sa 2.5. Pag guman yung divide, mo na nang bugawas na answer is positive 0.4. Yan. So, meron na tayong z-score which is negative 1.2, and dito sa kabila is positive 0.4. Yan. So, gagawa tayo ng chart. Ito na ating chart. Ay, gagi mali. At dahil tapos na tayong makuha ang ating z-score which is negative 1.2 and positive 0.4, gagawa na tayo ng normal curve, which is ito. Gagawa na ako. Dahil negative itong isa, negative 1.2, dito natin siya lalagay sa kaliwa. Ito. Yan. Negative 1.2. At itong isa, dahil positive siya, dito natin siya lalagay sa kanan. Yan. 0.4. Kuha nyo guys, ay classmates. Pagkatapos natin dito, matapos na tayo makuha ating z-score and dito sa curve, pwede na tayo mag-conclude dito. Therefore, the area of negative 1.2 and 0.4 are added. The answer is 0.5403. This means that Richard has a 54.03% chance of marrying between 26 and 30 years old. So, may chance daw si Richard na magka-married between 26 and 30 years old.